These are some examples that you'll see in Edulastic on solving linear system word problems. So take notes carefully with these, and then they'll help you with the assignment. So Brian's golf coach suggested he take some golf lessons. So there's a golf pro at Windy Fairways. So we've got one place here, Windy Fairways. They charge $20 per month. Here's our per month, plus, so we know that's an add, $10 per lesson, okay? The pro at Sunny Sand, so there's another place, charges $100 per month for unlimited classes. How many classes does he have to take for both pros to be the same price? We're looking for when they're equal. So when we're thinking about systems, if we were to graph something, we're thinking about where they intersect, okay, or when the same thing makes both equations true. So let's talk about making our equations. So the equation for Windy Fairways total cost. So remember, we're going to use y for our total cost, and we'll use x for number of lessons. So for Windy, we have to look at the Fairways. They charge $20 per month. So that's a set fee they're charging per month. That's not per lesson. We're using x for our lessons. So we know that y has to equal what we're charging per lesson is $10. So 10x, and then what our initial fee is, no matter if we take a lesson or not, just to have that membership there, is $20. Okay, so then we look at Sunny Sands. They charge $100 per month, but you get unlimited classes. So there's no per lesson fee. So if I walk into Sunny Sands golf place and ask the pro to give me lessons, he said, I'll charge you $100 and you can take as many lessons as you want. Well, if I never go for one lesson, I've still paid $100 for that month. So my total cost is going to be $100. Now, when we start thinking about what we have to do to solve, on this one, we see that they're both set equal to y, and we're going to set them, because y equals 10x plus 20 and y equals 100, we're going to set them equal to each other. So we would have 10x plus 20 equals 100. Now, when we go to solve, we think about just solving equations as normal. So minus 20, and these cancel out here. Now we have 10x left equals 80, and divide by our coefficient of 10. And now we know that x equals 8. Well, remember, x is the number of lessons. So the number of lessons has to be 8. So Brian would have to take 8 lessons for a total cost of what? So now to find out what y is, we can plug it back in. So I'll show you a quick trick in a second, but y equals 10 times 8 plus 20. Well, 10 times 8 is 80, plus 20 gives us 100. So y equals 100. Well, we already knew that because in this equation here for Sunny Sands, it told us that the total cost was 100, that y is 100. So we already knew that. So there's the first example. Now let's go to a second example. So on this one, we're talking about a marching band. You're the director of a marching band, and you have to order 35 new uniforms for the band. And it says the number of girls, so we're talking about some girls. So we'll think about girls being the G, is 5 more. Oh, wait a minute, they're telling us something about the girls too. So girls can be G, or girls can be 5 more than something, 5 more than twice the number of boys. Well, what are we using for boys? Well, I tell you here, we're going to use B for boys. So B is our boys. But in our other way to write for girls, we're doing 5 more than twice the number of boys. So twice the boys. So we've got some different expressions here that we can use. And it says, how many uniforms of each type should you order? So I need to know, how many girl uniforms should I order and how many boy uniforms should I order? Well, I know that I have to order 35. So think about what makes up those 35 uniforms. We know that boys' uniforms and girls' uniforms make up that 35. So that's our total number of uniforms that we need. So B plus G equals 35. Then it says an equation for comparison of girls to boys. Well, I have girls, but that's just girls, and I have boys, but that's just boys. Here, I have girls on one side and boys on the other side, so that's my comparison. G is equal to 2b plus 5. Now, we're talking about substitution. We already have one of these solved for a single variable, and that one is G. So we can use this one as our substitution, and everywhere in the first equation that we see G, we'll put in this expression 2b plus 5. So b plus 2b plus 5 equals 35. Now, we don't have anything to distribute here. These are just a plus, so we can just take this out of brackets. So b plus 2b plus 5 equals 35. We want to combine like terms. So we have a b here and a 2b here. So 2b plus a b gives me 3b's plus 5 equals 35. Move over your constant. We want to get our numbers together on one side and our variables with our coefficients on the other. So we have 3b is equal to 30. So this is multiplication. To undo multiplication, we divide by the coefficient. So we have b equals 10. So B, remember, stands for boys. So that means I need 10 boy uniforms. So here's there. And then I need a total of 35. So if I want to find out what girls are, if I go back up here and I plug in 10 plus what gives me 35? Well, that's 25. So I need 25 girls uniforms and 10 boy uniforms. All right, let's get to our final example. The final example has to do with money. So when we're thinking about money, we have to thinking about equation with a total amount of money and the total amount of coins or dollar bills or whatever they're telling us about. So in this particular one, I have 100 coins, and it says they're dimes and quarters. So my 100 coins are only dimes and quarters. The total amount of money is $14.05. It says, how many dimes and quarters do I have? We're going to use the variable D for dimes and Q for quarters. We're not going to use dollar signs in our equations, and our answers are going to be in dimes and quarters. So we have to first think about an equation for the total number of coins. Well, I have a total of 100. I know that. But what makes up that 100? Well, some dimes and quarters. So some D plus Q. Some dimes plus quarters gives me 100. Total coins. Now I need an equation for total amount of money. Well, I know that my total money is $14.05. So I can think about $14.05 being my total. But what makes up that for the dime? So we got to know how much is the value of a dime. Well, the value of a dime is 10 cents. And we write 10 cents as 0.10. So for every dime, it's worth 10 cents. Plus, a quarter is worth 25 cents. So 0.25 Q is for every quarter. In total, they have $14.05. Now we look and say, do we have a single variable isolated? Well, we don't, so we need to do that. So on the first one, they're alone. There's no coefficients. It's just a 1. This one, we can go ahead and isolate. So we'll get D by itself. So we're going to say D equals 100 minus Q. So we can use that for our substitution. So everywhere in the other one that we see a D, we can plug in that. So let's do that. So we have 0.10, and then we're going to substitute in 100 minus Q plus 0.25 Q equals 14. Oh, I ran out of room here. 14. Make it a little smaller. 14.05. We're going to have to distribute, so you can use your calculator for that and distribute. So if I have 100 times 0.10, that is not 100 times 10. It's times a tenth, okay? So a tenth of 100 is just 10. Then minus 0.10Q plus 0.25Q equals 14.05. Now, when we combine like terms, I have a negative 10 Q, 0.10 Q, and a positive 25. So two numbers are different signs. I find the difference. So 25 minus 10 gives me 15 Q, and I keep the sign of the larger one, so it's a positive. Rewrite everything else. And now I'm going to move over my constants. So minus 10, minus 10. Well, if I have $14 minus $10, I only have $4.05. And on this side, I have 0.15 Q. I divide by 0.15, 0.15, and of course you can use your calculator for that. 4.05 divided by 0.15 gives me 27. So I have 27 quarters. So 27 quarters. Well, to find the number of dimes I have, I know I had a total of 100. So I can go back and look in this first equation here, plug in my number of quarters. So I had D plus 27 equals 100. Solve for D. So I know if I take 100 minus 27, I'm going to get 73. So D equals 73. So I have 73 dimes and 27 quarters. And if I add that back up and plug that back into the second equation for my number of dimes and quarters, it'll equal $14.05.